Hello, this is Chang. Today I'm going to do a demo to show the usages for some of the tools utilities concerning universe recoverable file system. The first tool you probably want to use the UV regen -d. It checks the license packages of the installation. So we are pretty much concerned by the UV RFS package. So this is a fresh installed system. So I start the system. The tool I want to use for the game is the show UV. So as you can see, we have the system monitor, the sync daemon are running, and another tool we want to check is this UV IPC set. That's this utility. So for the shared memory, we have two entries for the recoverable file system. Those two. Those are the control area for the recoverable file system. This is the system buffer pages. For the semaphore, we don't have any. The message queues, we have those four. The first is dedicated for the checkpoint daemon. The last is for the system monitor daemon. Those two are actually shared by all the daemon processes, including the after image log, before image log, sync daemons, and so that's pretty much the tools we let me bring the system, change the system from write-through mode to full protection mode. After changing this, then the two utility I need to run is first UV regen. Sorry, I haven't stopped the system. So this will update the configuration file. And another tool I have to run is the UV control. That tool will actually reinitialize the login system for the recoverable file confirmation. So after this is done, I bring up the system. So we have more daemons popped up, and after image log, before image log, checkpoint daemon. So that's the UV control install, UV regen, show UV. The other utility it's new to universe. It's not in Unity. It's UV unload. What this tool does is, since after a file is cached in the system buffer, we don't allow anyone to remove the file from the operating system if the file is cached. So this tool will actually be used if you have such a request. Let me see the options. So we have a few commands here. Once can list all the files in the system buffer. We can remove the file, and we can relocate a file. We can unload all. This is you have to have some special permission with this. And also we can check all the files in the system buffer to see if there's any problem. Remove the OS level or those things. And let me try the first one. UV log list all. So this is a fresh started system, so we can see there are three files in the system buffer. The main account walk, the sysmessage file, the UV account file. So here is the same way showing how many processes are opening this file. It shows none of the file is open. Let me start a shell script. Sorry, universe shell. So once I start this shell, if I come back here, you can see there's one more log file, and the file is actually being opened. The message file is also being opened by the UV shell process we just started. Let me access our file here. So while we are waiting on the next page prompt, that means this those state files are this state file is being accessed by the UVSH process. And we can see that process actually opens 4 files. Those 4 files still opened by that process. One is state, the dictionary file, and the message file, and the work file. And to finish this, I completed the so those state file and the dictionary file are not opened by the process anymore, but they are still remain in the system buffer. So how can I get rid of these 2 files from the system buffer? This is another usage of the UV unload. So I can just here directly copy paste the full name and so let me double check. So those 2 files are completely offloaded from the system buffer. And let me create a file xyz. I mean, I can copy from I copied those artifacts to this file. So let me check that. So so we're still opening the message file and the work file. In the history, we actually access the XYZ file, the state file. Usually, we do we can do that to delete the file. That's for sure. And if we delete this file, the file are gone from the system buffer. But let me. So we have we created the file again. But what if I want to delete this file? I don't want to go through the for some reason I even don't know the work point, but I want to delete this file. This is what you can do. UV unload. I want to also delete the dictionary file as well. So I can remove this 2 file if I say they are gone. But I mean, by this way, of course, I'm left a work point in the work file, so I have to clean up the work file. That's pretty much what UV unload can do. Let's review the options again. First, we can list all files. We can remove the files. Even with some option like recursively remove a file, we can move the file different location. We can unload all. I mean, this is everything we want to unload if it's not still being open. So that's the UV unload. Another utility we want to check is the system. Oh, sorry, not system. UV system. The UV system gave us how the internal are performing for the system buffer. But this time we don't have any activities. Let me install this script you can download from Rocket Software for this MV University. So I want to install something to my my current directory is the demo directory, X demo directory. I want to install the paragraph basic program to. So it will create 4 files. Each of the files is 200K modulo. If the separation is 2, it's about 200K each of the file. Let me run one of the paragraph. It's called start with access 2 files, and with some of the multiplication ratio, delete ratio, and 250. So there are 3 phantom processes running there. Let's look at this side. So as we can see, the hit rate about right now is 87% because we have 200K of the modulo, and it takes time to touch every module of the file. So the file is still being loaded into the system buffer. The first section is the block index group, big statistics. This tells how many blocks we are trying to pin for read operation, how many blocks we are trying to pin for write operation or delete operations. Those are the queue, and those are the how many hits. So we found the page in the system buffer. Right now, since all the pages are loaded in the system buffer, remember our system buffer is 500 meg. So those 2 files only take about 400 meg or so. And so we can load the pretty much every file loading into memory. And those sections are latching. So in case you are seeing this number, you are performing not good. So we can look at those numbers. Those are weight, latch. Usually we have conflicts in some of the places. Those are the log statistics. For example, this one is during this time period, how many blocks after image log blocks are flushed, how many before image log flushed, after image log are flushed, and those how many log flow or log overflows we have running into, and how many log have been switched. This number we pay more attention to. Each of the log switch corresponding to a checkpoint switch. This is a very activity intensive application, so it generates lots of writes. So the system, our logging system is setting so small it cannot handle this well. In your real application, you have to set in the log file size appropriately. So this checkpoint switch happens between a minute, 2 minutes, or 5 minutes is optimal. And this just switch too quick. Almost every time we during the time displaying period, we can see the checkpoint switch once or two. But anyway, this is just a concept showing how they perform, the system buffer are performing. This is the system throughput for the system buffer. So at this point, we can see we can handle 800 or many operations, and per display, I think that's 3 seconds. So let me stop the test. Remember our test, it was we start some background process active 2 files. Let me start some same parameter, but with 4 files. So we can say we active 4 files. In the previous running was only use 2 of the 4 files. Now we utilize all the files. So we can see we are now accessing 4 files. The total size of the 4 files is about 800 meg. Our system buffer is about 500 meg. We can see the hit rate a little bit dropped and to 77%, and the system throughput are dropped because our logging system we generate so much logging before image, after image log, drag our system. If we have a very good logging system setup, you will have a much better system throughput. So that's pretty much the I stopped the test. I quit this system. The other utility I can use. Let me run the test again. The another utility is the UV state. This is pretty much internally used by the engineering or by the support people. But one of the operation I think is pretty useful is called the waiting state. Sometimes you found your system is stored there and not moving at all. You probably can check this then, for example, this one, because this is a dynamic information, how the system are waiting. And so one of the usage, so I want to dump the live data into a dump file. So after that's done, I can stop the system. Make sure all the data is gone. Then I can stop the whole system. But if this file is sending to rock software engineering, we can re-verify the file to check at that time what happened. This become static. So this is all the tools I want to introduce to you, and I hope those information can help you in tuning and configuring the universe recoverable file system. And thank you so much for watching this video. Thanks again.